Everyone, welcome to Microsoft Reactor's Build Skills session on clean and prepare data using Python. I'm Justin Garrett. I'm joined by Ricardo Prinz, and this is our second session here in the Data Science Build Skills track, right, Ricardo?
Yeah. Hello, everyone. I hope you guys like this one. We're being very excited in our discussions about the content we're going to present, and hopefully you guys are going to enjoy it.
Yeah, absolutely. So like I said, this is the second in our series. However, you don't need to have prior knowledge to what we did before, which was an introduction to Jupyter Notebooks. In fact, today we're going to open up a Jupyter Notebook right in Visual Studio Code. And we're really going to explain what it takes to clean and prepare data, which might sound like, oh, I got to clean, I got to prepare. It sounds a little bit like chores around the house and things like that. But the reality of the matter is that cleaning and preparing data and getting data sets ready for use is oftentimes, many data scientists say, it can be 70 or even 80% of the work, because you're dealing with data sets in the wild with millions of rows of data and things like that. And sometimes that data is not ready to really unlock that incredible insight that you can get from it, let alone joining data sets and really creating some great combinations and things like that. So we're going to talk about that today and really end with some pretty cool visualizations and things you can do using the Pandas library, amongst other things. So welcome, Reactor community. Students, many of you are joined here by our Microsoft Learn student ambassadors. This is overall our program. Ricardo, you are a Microsoft Learn student ambassador. Thank you for being that. But if you're joining us here, one of the things that we're offering with this session at the end is a Q&A, and also all of the materials that we're going to share here today are available on our GitHub as open source. So if you are a teacher, if you're an ambassador, if you're just an able-bodied STEM volunteer, you can teach these workshops yourself to your own communities with our materials as well. So keep that in mind as you're thinking about this as well. Finally, I do want to just share, this is a Microsoft Reactor event, and we have a code of conduct. Obviously, please be respectful, be polite, treat Ricardo with respect here as he shares a little bit more about what we're going to do and such. But more than anything, log into your favorite chat platform and share your voice and ask your questions, because that's really what we care about, is to get interaction from you and hear you learn from us and together in this sense as well. I mentioned earlier that this is part 2 of 2. We do have a link there for last week's session. It looks like it's in our chat window now. And it was a really good one. I enjoyed that a lot as well. All of our sessions on YouTube are available on our Microsoft Reactor channel as well. So with that, let's go ahead and open up Microsoft Learn. You can follow along with us today. We're going to talk about your environment, so you can also follow along with us in Visual Studio Code if you did the prereqs in this workshop. It does take a little bit of work to get your environment set up. But everything you're doing here, you can follow along directly at aka.ms/clean data in Python. And that's probably going to be the easiest way to follow along with us today, like I say, unless you got your environment up and running, which hopefully some of you do. That's great. Finally, in order to set up, these are the sort of things. All of this is free, just so that you know. It's available in open source. But the tools we're working with today are Visual Studio Code. We have the Python installed natively on our devices. We have the Python extension in Visual Studio Code, as well as the Jupyter extension. That's basically what allows you to run Python runtime and the Jupyter experience. That is the ability to basically play and reset code in Markdown and code buckets. Check out our last session on that as well. Very powerful. Like I say, doesn't cost anything, because ultimately you're running the code on your local device, so you're not consuming any cloud meters or things like that for this effort as well. And then more optionally, you can download the Anaconda environment or the data science environment in VS Code. Really good idea to do so, particularly Anaconda, because it has lots of great things that you can use there. But as I learned as I was prepping for this latest one, pay attention to what version you download, because there's a lot of versions of Python. In this case, I think we're using 3.9.10 with the Anaconda environment as well. So with that, we're going to really explore data frames today, really working with powerful data sets that allow us to perform computation on a larger data set. So everything we use may have, up to 600 lines or even just 5 or 10. But you can imagine if you were to use a data set with millions of rows. Some of the things that this Pandas library allows you to do is perform some really, really amazing calculations on data and manipulation of data with relatively low computational effort. And that's really what NumPy and also Pandas was really designed from as well. And so we're going to show you that. We're going to show you some of the situations by which you might be able to work with missing data, remove duplicates. These are fundamental, foundational things because anytime you work with a data set, you're going to see duplicates in it and things like that. And getting rid of that helps improve your analysis. We're going to show you how to combine data sets as well. Again, that can create some of the most powerful insights. And then finally, we'll use some exploratory statistics and visualization on this as well. So with all of that, I'm primarily going to hand it over to Ricardo to lead our workshop today and walk through. I'm going to be available in the chat window. I'm also going to challenge you with a little bit of why questions and some of the exercise, or try to, for those of you who are a little bit more advanced out there as well. But with that, let's go ahead and turn it over to Ricardo.
All right. So let me first share my screen here. So for this presentation, I am not running Anaconda here, but if you follow along and use the instructions using Anaconda, you're going to get the same result. For those curious about what I did, I'll just explain briefly for a couple minutes. So I am using environment here, like a Python environment. So these are the commands, just like I did last time, Python 3-m virtual env venv, and then it creates this folder here. I activate using this command because I'm on Windows. If you're running on Mac or Linux, the command is a little bit different. You can Google that. And then I have installed all the libraries that I need to use for this tutorial, which is the kernel for Jupyter Notebook, NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn. If you have any questions on that, I advise you to Google or just post here on the chat, and to the extent that we can answer them, we'll do so. But let's go ahead and get started with the data preparation and cleanup. First, let me just zoom in.
Oh, thank you. I was just going to suggest you might zoom in just a little bit. That's about perfect. Maybe one more for some people.
Yep.
As well.
Is this better?
Yeah, you can see your Python 3 activate virtual environment now.
Okay, perfect. So I was talking to a friend. He's from a business background, and he was asking me what kinds of things that he needed to learn, because he's now diving into a data science position. And the things that we're going to talk about are going to cover pretty much the same thing that I talked to him about. And some of the things that Justin said, unfortunately, real data is messy and far from ideal in most of the situations. And if you've done this for a little longer, you might remember having to go through long Excel spreadsheets and checking for data using either the Control-F functionality or not so efficient information. And what we're going to show you some more efficient ways using Python libraries to do that. We're going to explore initially a very known data set called the Iris dataset. And let me run this cell. Again, this is a Jupyter Notebook. If you don't know exactly what that is, if you've missed the previous session, you can just go there and take a look, and it will be clearer for you. Oh, let me do this. Okay. Yeah. So now it's going to work. So I'm using Pandas to display the data. The scikit-learn data set is being imported here. It takes a little while. Remember, I'm not running this on a cloud environment, so it's a bit slow. So 13 seconds, it loads the data. And let's take a look at this data set. So if you do the dataset name.info, the method, it's going to explain. So this data set has 150 entries, so 4 columns that are type float. And if we want to take a look at the values in each of these columns, you can use the head method. And if you hit it, it displays the 5 first values. So we have a few exercises here that you will take a look. And if you're going through this on the Learn module or on the GitHub, you can take a look at these later. I'm not going to cover each of these exercises, just a few, to give you an idea on some specific topics. If you have any questions about that, you can probably post it on the chat. So similar to the head method, we have the tail method. If you see here, I'm displaying the first 5 values, and you can use tail to display the 5 last values. And as I said before, I had 150 rows. It goes from 0 to 149, so it's displaying the values here: sepal length, sepal width, petal length, and petal width in centimeters. And it's particularly useful to take a look at these values if you're starting to work with a data set, just to give you an idea if you have outliers, empty values, null values, or duplicates. And we're going to cover a little bit of how you handle these things. It's not in the scope of these presentations to describe specific research techniques or when do you do one or another, but rather we're just showing how to do the things. So let's start with dealing with missing data. So it might happen that if you're dealing with a larger data set, that some of the values are absent. If you look back here, I have 150 non-null values. So this initial data set we're looking for, it doesn't give us problems, but this is not what usually happens. So sometimes you're going to have values that are missing. Sometimes you're going to have values that are not there simply because the person collecting the data didn't have access to them. And you have 2 types of missing values, one that deals with non-float values and another one that deals with float values. So I'm not going to go through specifics of when to use these. I'm going to show a few examples of how both NumPy and Pandas will handle these values. So let's start here by creating an array with 4 values. I'm going to 2, none, 6, and 8. And as I said before, none is a non-float data. So once you use the none, it's going to create, instead of a numeric value data set, it's going to have an object type. And you'll see the implications of this later on as we go through. For example, if I try to use sum to concatenate the values here, it's going to give us an error because for object types, I cannot use aggregations. You can read about this a little bit more and understand the limits of that. Just have this in mind while we go further, and then you'll understand the importance of paying attention to these things. So Pandas and NumPy, they support not a number, which is nan. Some people call it nan, others call it not a number, which is going to handle empty values for floating numbers. And you can see you can operate these values, but however, they will just return not a number as a result. So both adding and multiplying values with not a number as empty values will return not a number as well. And the good thing about this is that once you use not a number, remember the problem that we had here with aggregation functions like sum or minimum values here? They will work. However, they will also return not a number. And pandas here, it's going to return it a little bit different. So let's do the same thing on pandas and create a series of values here using 1, 2, 3 with integer type. And if you look at it down here, it creates the values, it assigns it as an integer, 32. But once we change one of these values, and I'm replacing here the value 2 for the value none, what it does is it automatically is going to convert that to an object data set. And again, all the problems and implications of that are going to happen. And just have this in mind and why it's not ideal to have empty values in your data sets. Now that we've taken a look at that and how these empty values are handled, let's take a look at what we can do to deal with missing values in our data set. So we're going to basically talk about 4 operations. We can just summarize as 3. Is null or not null, which are Boolean masks that are going to be generated to display whether a data set has null values or empty values or not, and how to either drop these values or how to fill these values with a specific value that you want. So first, we can detect whether a data set has null values by running a command like is null. So first here, let's initialize a series on pandas using 0, not a number, an empty string, and none as a value. So if we run is null, it's only going to return true or false. True if a value is null, or false if a value is not null. And if you take a look at these results down here, for values 0 and 2, it returns false, because even if 0 is 0, it's technically not null. It contains something there. And the same thing applies for the empty string, as opposed to not a number and none. So both these 2 types are used specifically to show that a value is empty. So the same thing applies for not null. If I were to run here instead of is null, if I were to run not null, the output is the inverse. So 0 and 2 are not null, which are 0 and the empty value, empty string, and the other 2 are going to return false because they're actually null. Now, let's take a look at how do we drop these null values. Again, just emphasizing here, we're not discussing when to do these things. We're just telling you how to do them. Okay. And let's run this example 3 and drop the null values just to see what is going to happen. So if you do this, you will see that the output is just 0 and the empty string, which is similar to that if we were running this. You see, it only takes the values that are not null. But instead of just displaying them in a indexed way, it is actually going to drop these values from a data set. So be careful with that. If we're running with data frames instead of series, because of their multi-dimensional character, there are a few additional options that we can talk about. So let's create this data frame with this structure here, 1, 2, and nan 5, 6, 7, 8, 9. And if you look at the values down here, if you pay close attention, although we pass them as integer, the moment we assign a column value of not a number, it will automatically convert that entire column to a float instead of an integer, so that it can fit the object there. So differently from a series, you can't just drop one value here. You have to either drop a row or a column. Since data science considers columns usually as features or variables, the standard or default value, if you just do drop an A, is to remove the rows and not the columns. So let's say if I run example4.dropNA, I am going to drop rows 0 and 2 because they're both containing empty values. You can, if you need to, specify as a parameter the columns or 1. And if you run that, instead of deleting the rows that contain not a number, it's going to delete the columns that contain not a number. And as a result, you're going to see that only the column 2, which contains the 7, 8, 9 values, is going to be maintained. So this is a bit dangerous, as I said before, because you can end up deleting everything. And we're not always sure if that's the best way of dealing with empty values. So you can use a few parameters like how and thresh. And there are additional parameters. And as I think that we have already responded that if you do example4 dot drop NA and then a question mark and you hit enter or hit play, it's going to show you all the parameters and all the details of the things you can do to how to have the specific details on how to drop these values, additional parameters, and all the more information here. So as we've said here, if we just use a threshold of 3, for example, I can, let's create here. So I'm going to create an additional column only with not a number values. And then I'm going to drop all the rows that have a threshold value of 3. And here, the only one that's going to be kept is number 1, which is the only one that has 3 values, at least 3 values that are not a number, and deletes 0 and 2 because they have 2, only 2 values. Not only you can drop these values, as I said before, but you can fill these null values and replace them with something else. Let's have another example here. Let's say, for example, I have this series 1, not a number 2, not a number 3. You can fill out all the empty values with a single value, such as 0. And then, as a result, you get another float. And let's see what happens if instead I fill it with an empty string. So it does the same thing. It fills it with an empty string. But instead, if you look at the data type here, it's now an object and not a float. Again, I'm just giving these examples. I'm not going to go into big details of what happens when Python internally changes the data type here. But have that in mind. If you have larger data sets, when you have object, the calculations are going to be a bit slower and things like that. Just have that in mind while we go through. You can also specify how do you fill these. So if you use a method of forward fill, let me just go back here. Just change that as 0. So you can use forward fill and backward fill. So if you do forward fill, it's going to use the last value to fill in a null. In that case, the last valid value, remember, columns, rows B and D were no values. And then it takes the last one, which in case here, it's the A. And in here, it's the C. And then it copies these values and it fills it that way. Similarly, you can backfill to propagate these values. And you obtain a similar result. But B, instead of taking the value from A, it takes a value from C. And so on and so forth. So if we run data frames, remember this data frame that we had before, you can also fill these values. But as you might be guessing, you need additional parameters because you can take rows or columns just to consider. So let's take a look here. We're going to use forward fill, which is going to take the previous value, and we're going to use axis 0 here, which is the column. So if you look at this example and compare, it's going to take the not a number here with the previous value is 1. It's going to copy the 2 here. And the same thing for the other ones. But look how interesting. So for the column 1 and 3, if you see, not all the values are going to be filled because of the method we chose. So since forward fill takes the previous value, so for the column 1, since the value at row 0 will not have a previous value, it's going to persist in our result the not a number. And for 3, none of the values here are valid, so it's going to maintain them. And if you do the same thing for a backward fill and axis 1, or you just play around with it a little bit, you're going to see that according to the disposition of your not a number values and the rows and the columns, you might end up not filling all the values. So you can also be creative. Let's say, for example, I want to fill the value as an average or the mean value. So I can take the example 4 and I fill all the not a number values with the mean value. And the output here, so for the first one, it's going to take the average of the row, the column, which is 1.5 here, and the similar for the other one. And for the column 3, all I'm going to have are not a number values. Again, these are all empty values, so they don't have a mean. So the default is going to fill in row-wise. And again, if you want to go further into additional techniques and stuff on how to deal with that and how to fill and clean and other advanced techniques, you can feel free to browse around documentation or go online to learn a little bit more. So now let's cover how we handle duplicate data. And as an example, let's create another data frame with the letters and numbers. So let's go A and 1, B and 2, A and 1 here, B and 3. And if you see, I have a few duplicates. So I have values A1 on the rows 0 and 2, and rows 3 and 4 are also duplicated. So I have a method that's called duplicated. And if I run here, you can see it's going to return false and true according to whether that particular row is a duplicate or it's a unique value. And if you notice, it's going to consider the unique value the first occurrence of that value. And if you compare, for example, columns 0 and 2, which have the exactly same value, it's going to display 2 as a duplicate one. And if it had an additional one, let's say if 3 was also in 1, 3 would also be displayed as true, and so on. But let's take a look at what we can do. So let's run drop duplicates. If you just do that, it's going to delete rows 2 and 4. Remember, the default here, as I said before, we're thinking data science. We're thinking that the columns are features, so they're going to be maintained. So it's going to, by default, delete considering the rows. You can change that. You can add additional parameters. Let's say, for example, I want to consider the column letters as a parameter. So if I run here, since if you look at our example here, the values are A and B, the unique values, it's going to keep only the first occurrence of the letter A and the first occurrence of letter B, which are the rows 0 and 1, and it's going to delete everything else. So this is a very essential things dealing with duplicate values, dealing with the empty values. We're not going to cover everything here, but just bear in mind there are many powerful methods of handling these. Let's talk now about how can we combine data here. So in real data, in real life, sometimes you have more than one data set containing information that you want to work from different data sets. So let's say, for example, I have two tables here, two data frames with employee information. And we have one that is going to list which group does the employee belong to, and another one that is going to list when this employee was hired. I can combine these two using the merge function. So Pandas by default is going to look for columns with the same name. So in here, since these two have the employee column here, if you just do pd.merge and then you pass the data sets, it's going to return a new one, the concatenated value, and it's going to consider the matching values. For example, Stu here, it's going to list as being hired in 2012. And if you look here, even if Mary is listed as first on the second one, it's going to take the ordering by the first one that it was passed. So Mary's 28 hiring data is going to be displayed correctly here. If you've done SQL before, if you've handled all of these inner joins, outer joins, and all those complicated things, we're not going into this, but just bear in mind that all of these are present here. I'm just going to give you a few examples on how you do that.
I was going to make a mention of that, Ricardo, that I got my start in SQL doing this and what inner and outer joins are. And so like for some of you that have done that before, it's like, oh no, it's back.
Yeah.
But yes, if you're very curious about more information on what an inner join or outer join is, we've got a great Microsoft Learn module on that using Transact SQL as well. But in Python and other languages, in fact, we have similar concepts, right?
Yeah. And yeah, it's not going to haunt you in your dreams or anything. I'll show you how powerful tools such as Pandas handle these things. So let's say, for example, let's create another group. So you see here, we have accounting, we have marketing, we have HR. And let's say, for example, I want to add supervisor information for these. And since we have two employees that work for marketing, that can be kind of conflicting. And you can imagine that if you were doing this with SQL, it would be a little trickier to do that. But if you just take Pandas, it's smart enough to recognize and just to make the necessary adjustments. So you can just pass the F3, the F4, which are these two resulting ones, and it's going to give you the right information. So it's going to take Giada, which I've pronounced that way, which is the marketing group supervisor, and it's going to put in the corresponding rows. So the resulting data frame is going to have the right information there. You can also specify, again in here, you can also specify which column you're using as a parameter. And it's actually good practice to do that to avoid ambiguity. So again, here we're dealing with simple information, just 3 or 4 rows and 3 or 4 columns. But in real life, you might have to handle 150,000 columns. And this might be quite problematic. So it's a good idea just to specify in which column you're basing your parameter of merging into. So if you see here, the output of these two is actually the same because it's going to consider the common column, but it's just a good idea to specify here. And here's how you do it. You just put the on parameter, and then just the value of that parameter is going to be the column with which you're going to consider your merging. Let's have a more complicated scenario. Now I am going to add a few core skills, and I want to display which employee in that group will have a specific skill. So yes, responding to a question that I just saw by Ravi, if you do on, it's going to be much faster. Yeah. Mm-hmm. And let's take a look here. So I want to display this new result. So a new table that's going to display that Gary from accounting has as core skills math and spreadsheets, and so on and so forth. Again, here I have passed the group, as a parameter to make things faster, because it's going to tell pandas which column to use and how to display the data. It's not always the case that you will have this perfect scenario in which the columns are going to be named exactly the way you want them to do. Of course, you can always go there and rename them, but there are ways of not needing to do that. So let's go ahead and take a look at how can we do some of these things. If you use the left on and right on keywords, again, these left and right concepts, I think we posted the link on the chat. So feel free to browse around to understand left and right here. But just for now, think that we're taking the left to be like the main data set in which you're going to combine, and the right. So I'm taking this new data frame here that is going to contain salary information. If you take a look, it doesn't have employee as a name. It has name as a name. So if you just run the command df1 and df6 without specifying anything, you might get a problem, because it's going to see that you don't have matching columns. But you can say that the left, which is our df1, is going to be joined on employee column, and the right one is going to be joined on the name column. And since these values can match, the resulting will be the new data set that will contain the salaries according by name. If you look here, it's repeating the column employee. You could actually go there and delete this. You can use drop and just take a look at the documentation. How do you get rid of this column? On a similar way, instead of just using the column name, you can set up a column to be the index, or if you have here, if I run this, let's create 1A setting employee as an index. And look here, we normally have a numeric index, but if I set this index to be employee, the employee name starts to be in the index now. And if I do the same thing for df2, I will have the hire date and employee in a similar manner, considering as a primary ID here employee. So employee starts to be a primary key for these two. And if I run here left index true, right index true in the merge as parameters, the result is a similar one. But instead of having a numeric index, I'm still having employee here. Again, in this case, you need to pass two parameters, or you can use combining index and on, as we've seen here, left on and right on. You can combine them, left on 1 and right index true or false. So you guys can play around with this if you want to see how it works. We can also use the join method. The join method will assume merging on indices by default. So if I just run here, df1a join df2a, it's going to take the employee as an index because it's been indexed, and it's going to get the same result. And as I said before, you can merge and mixing the index and the on parameters, and you will get the same result. So let's understand a little bit on the many-to-many joins and how the set arithmetic works. So let's create this example here. You have group engineering as math core skills, marketing, writing, sales, and communication. And then let's run a merge of df1 with df5, which is this one, on group. So now it's only going to take marketing examples here, because if you looked at df1, the only common value, let me go back here a little bit so you understand what I'm talking about. So df1, it's the first one. 3, 2, 1 here. So I'm taking marketing, guys. And these are the only ones that are going to be displayed on this one. So since we have made a group here, and only the only marketing, the only column that had rows in common, the only row that had values in common with these two was marketing, only the marketing values are going to be displayed, since engineering and sales were not present on the first one, which is the intersection of these data frames. And if you've done like the inner ones, and again, go back to that if you want to learn a little bit more on the specifics on that, which is again the same thing if you run merge using inner. So again, you can, instead of inner, which is the default, you could use left or right, and then you would have, again, accounting and HR. Since they are absent from these values here, what pandas will do is going to drop not a number, and you're going to have empty values on your result. So if you have bigger data sets, you may end up having some conflicting names. Okay, let's run a few examples just to see what we do if we have columns in two data sets with the same name. So here I have this new one that would take Gary, Stu, and Mary and Sue, and we'll assign them a specific value here for rank, and another one that will give them different values. And let's say these two things are important. I want to keep them. So if I just run this, it is going to, if I specify that I want to merge them on name, it is going to append X and Y corresponding to possible alternate names, so I can keep the values without losing data here. So you can also specify different suffixes so that it adds. Again, if I run this, specifying this parameter here, it's going to add, instead of X and Y, rank left. So the left table here, it's going to yield 1, 2, 3, 4, and the right one, 3, 1, 4, 2. So they will only work if there are, they will work if there are multiple conflicting columns. Let's say, for example, if I had like a name of vehicle here, a name of vehicle here, or something like that, it would append these suffixes just to identify that this column came from the left data set and the other one came from the right, or X and Y if you just leave the same. So let's quickly talk about concatenation here. For NumPy, if we're using one-dimensional arrays, and if I want to concatenate X, Y, and Z values, so you just run dot concatenate, and it's going to take 1, 2, 3, which is the first one, 4, 5, 6, 7, 8, 9. And for two-dimensional, it's similar way. If you concatenate one and more, X and X here, you're going to have 1, 2, 1, 2, 3, 4, 3, 4. And again, we're passing axis as a parameter because this is a multi-dimensional array. And 1 is for columns and 0 is for rows. So if you do that in Pandas, you have the concat. And it's going to work similarly. If I run here, if I have a series that displays the values A, B, C with index of 1, 2, 3, and D, F with values of 4, 5, 6, and I concatenate these, it's going to have 1, 2, 3, 4, 5, 6 as a new series here. Again, with multiple dimensions, it takes these two and concatenates A, B, C, D, A, B, C, D. So it preserves the indexing, even though that it was duplicated. If you take a look at that, You can reindex it by passing the parameter ignore index. And the result would then have values 2 and 3. Again, on pandas, the default is going to concatenate row-wise with axis equals to 0. And you can change that. If you just put axis equals to 1, it's going to be the same thing, but column-wise. As you can see here, now instead of having the values piled up by rows, you can have them spread as in columns. So if you do that and display here, it's going to display fine. But if you try to assign this result as a new data frame, you're going to get an error because column names on pandas, they have to be unique. This would be a problem. Again, remember that pandas considers that we're handling data science, and so it treats columns as variables or features. Therefore, they cannot have a duplicate name. How do we do that with joins? So let's run this example here. Let's say I have this data frame, A, B, C, D, E, F, and this another one, U, V, W, X, Y, Z, and I want to concatenate these. So by default, it takes an outer, but I can pass as an inner join. And it'll only take the values that are corresponding, that are matching in the two of them, which is columns B and C. So again, just the same way it did before, it's going to fill out the empty values with not a number values. So there's another option. You can specify directly the index of the remaining columns if you just pass join axis. And then as a result, okay. Oh, no, never mind this. So never mind this. This was removed.
Yeah, I think this was the one that's been removed from the latest version.
Removed the latest version. So
yeah, it's sorry, I alluded to this earlier that I was running Python 3.9.10 in Anaconda, but if you use a different environment, this particular one, that it was interesting though. I was also practicing. We're going to talk about Append in a minute here, but Append is one of them that is being considered for deprecation and using a different function in the future too. So I think the lesson there is, for all of you who are learning and stuff like that, like the community is always improving these libraries, but also changing them. And so sometimes they warn you, sometimes they don't.
Mm-hmm. So moving on. We can append, because direct array concatenation is something that we'll work a lot with. So both series and data frame objects will have an append method that can do the same thing. So instead of doing pd concat df9 df9, you can just do df9.append df9, and it's going to take the new df9 and append it to it. Again, it's giving me a message. So the append method, it will be removed soon. So let's talk about the cool part now. Statistics and visualization. So it's very common that when we start to work with a new data set, we don't exactly know what we're dealing with. Or we're just talking about a huge one, and we want to know a little bit more about that. So we can run exploratory statistics and visualization tools just to have a bigger idea. For this one, we're going to use the Boston housing dataset, which again, this will be also removed from the future versions of scikit-learn. So we're here reading it as directly as a CSV file. And then we have, it's a dataset that will be displaying information collected from Boston area, 1978, so crime rate, and all these informations. So let's say I want to know a little bit more about that. If you run DataFrame.shape, it's going to give you, okay, so this has 506 rows, 13 columns, and I want to get a better description of what's going on in that data set. So you can do df.describe, and then this method will give you a count. So if you see that I have 506 values of each of these, the mean, the standard deviation, the minimum value, the percentiles, 25th percentile, 50th percentile, 75, and the maximum value. So you can also examine specifically which values you want to do. Let's say I want to look at the MED-V, the mean of that one. And if you run here, it's going to give me the 22.53, a whole bunch of other numbers, which is correspondent to this value down here. And the same thing, max values. It's going to display 50 here, the same one. And you can take and look at the median, and it's going to return the median of the age. So there are several descriptive statistic methods that you can use. You can use them per column. You can use them directly. And you can do some aggregations as well. Let's say, for example, I want to take a look at the average MED-V, which is the median value of owner-occupied homes, for each value of age. And if you run df.group by age MED-V.mean, it's going to do exactly that. So for age 2.9, age here is it's not the person's age, it's the proportion of owner-occupied units built prior to 1940. So 2.9, 26, 6, and so on. And you can do the same thing with other descriptives as well. You can do the max, you can do any other types. Let's say, for example, I want to check only the ages of more than 50% owner-occupied homes built before 1940. You can use a lambda function here to create a new column that is going to display that information here. So it's going to take the original one and take x greater than 50. And then if you do the value counts, how many values and how many false. So 359 of these they match. They were built before 1940, and 147 they weren't. And you can do the same thing using group by statements and take the MED-V. And you can do, as you see, you can do all sorts of different visualizations and analysis. Again, this is not meant to teach you all the techniques. It's just to give you a broader idea of the things you can do. Let's say I want to group them by age 50, red, chas, and then take the MED-V here for the means. And you can see for each of these the values. So these are the true values, are age 50 plus, and then the values according to the parameters you've passed here. So let's take a look at what we did here. So the first row, it's going to report the communities of last half of the houses built before 1940 with their highway access index of 1. And they're not situated in the Charles River, have a price that is around 24,667. This is $19,700 value. I wish I could buy a house with 25K.
Slightly more expensive now, isn't it?
A little bit more, yeah. And so you can draw insights from that kind of information. Again, remember, if we're just dealing with data, you can just study it, use these tools to study the data you're handling a little bit more.
And I'll just add real quick here, Ricardo, because it's been a theme in the chat window today too, is like, why use DataFrames versus NumPy or Python without a library or things like that? But you can see how powerful it is now to manipulate data for analysis purposes this way. So now we're drawing correlations, we're going to visualize data. And so the DataFrame is perhaps a little bit more work up front for the cleaning perspective, but then it's so much more powerful computationally, isn't it?
Yeah, for visualization, there's no question whatsoever that using pandas is going to improve significantly the kinds of results we can extract from that. Yeah. And once we get to the visualization point, we'll see the power of that. And again, let's display the same data, but just unstacking this just to make it clearer. and then it just displays the same thing, fills up the NP values, and so on and so forth. So we can also check for non-unique values and then for unique values, so which are the unique values, 0 or 1. And then you can count. So if 471 of the chess column are 0 and 35, they're 1s. Or, which is the power that we're going to show. So you can display graphs. Now let's use Matplotlib here. And you can plot a bar graph just to visually see. So these are the 400 and something values, or the value 0, and less than 50, because you see it's like 100 here, so 50 is probably halfway through, so a little bit there. You can also edit this. You can also run correlations here. So let's run a linear correlation, and you just pass the Pearson, also known as Pearson correlation here. And it's going to show the correlation of the variables. So how it's crime. So for the column here, for the diagonal here, it's always going to be 1 because it's the same one. So how is the crime correlated to Zn? And it's going to show you the R value for that correlation. And you can also compare and analyze your data that way, just to have an idea what the data you have can say to you. Now let's take one of the columns and do the correlation. You can also do that. So I want to correlate everyone with age. So let's take a look here. And then you have the corresponding value here. So age 50, which is that one. And then it's going to be 1, and age 50 with age, and with so on and so forth. And you can see the correlations here. So you can also, as I see here, I have passed an argument just to sort them with a descending order, just to identify patterns. So with age, it's trivial because, I mean, we're talking about age. But you can see air pollution values are the next ones that are correlating well with older houses and so on and so forth. And you can draw stuff. But let's take a look at how can we display these in a graphical way. So the Seaborn library is going to offer us a few additional options. You can plot a heat map that is going to display the correlation. Again, the darker values are for stronger correlations, and the diagonal one is always going to be 1 because it's comparing the value with itself, and lighter values are weaker correlations. You can also display them as histograms. And then you have the same thing in here. And let's take a look at additional ones. So you can, the default bin size, you can also specify. Let's take a look at like a different one. So you just, if you add more buckets here, your histogram will be a little more complex. So Seaboard, so I've been doing this with Matplotlib. Let's do it with Seaboard. So it is a little bit better because it's going to also do a KDE plot here. Again, so if you want to know more about what these are, you can dig a little bit more on the documentation.
Yeah, I think Matplotlib can be useful for just simplicity and quick analysis, easy to customize. Seaborn tends to be a little bit more fully featured, but maybe you can't do quite as much with the stock graphs that are shown as well.
Yeah, and there are some pretty cool visualizations on Seaborn. Let's take, for example, this one. You can do joint grips combining histograms with scatter plots. And yeah, it's kind of tricky to read, but depending on what exactly are you working with, you can do all sorts of possible combinations here. So I can customize the visualizations, and you see all these are the same colors. I can change the density of the dots and things like that. And I can do a 2-dimension KDE plot. So darker colors are stronger correlations and lighter colors are weaker. No, this is like, sorry, a higher concentration of points. You can do pair plots. It's going to take a little bit more.
Yeah, this one takes some time to load.
Yeah. But then again, you have all sorts of possible visualizations. It adds it's going to give you the concentration points. It's going to give you like an approximate regression equation line here, and so on and so forth. So there are many, many things you can do. Again, the idea here was to show you the power of Python to clean, to prepare, to analyze data. If you want to dive deeper into that, I strongly advise you to go further into the documentation or other. I'm pretty sure there's a very extensive data science tutorial on Microsoft Learn that you can also refer to.
Yeah, absolutely. This is just one of many. I think this is, the third in the series that we have behind just learning Python for absolute beginners and using basic syntax, as well as our Jupyter Notebooks. But thank you, Ricardo. That was wonderful. I went end to end from, that's a lot of density of content in about 45 minutes to 50 minutes of runtime there. So thank you very much. If you all out there missed any of it, obviously you can check this out on Microsoft Learn or to pull up your own Jupyter Notebook in VS Code. As well. I really do like using VS Code too, because running the actual cells help me kind of understand and experiment, and then really working through the exercises and things like that as well. So again, thank you, Ricardo. And just of all of you out there, just a quick reminder that if you're interested in running this workshop yourself, we have all the speaker prep and materials to use this in your own communities as well. And there's lots of other things you can check out, getting more into advanced Python and other things as well. So with that, we wanted to open up for any other questions that you might have on this. If you're a student and you're interested in being a student ambassador, obviously you can do what Ricardo did in today's session, which is have that opportunity to present on a live stream professionally as well. And if you're part of our Microsoft Reactor community, we've got lots of great things out there for you as well. So again, thank you, Ricardo. I really appreciate it. I learned a bit more. I do every day, especially that error message that happened on the version. It's amazing how a Python changes and such too. So please ask your questions in the chat window. Otherwise, thank you very much and have a great day.
Thank you for enduring.
That was great.
Not an easy topic. Yeah.